Hi everyone, welcome to Beyond the Grid. We are here live and in person with James Feasey today. Every company needs a suave British guy who can rescue people with, a ballpoint pen. That's our James Feasey. So we're very excited to have you on the show today, James. And while you may not be rescuing people with ballpoint pens here at Endeavour, I'm so glad that you agreed to do this podcast today.
I used to prefer underwater knife fighting. But
Is that really what it was?
no, but it gives a good visual.
Exactly. Now I have a whole different image of you,
Yeah.
so we'll go with that. But when you're not doing that underwater knife fighting, let's say, what do you do for Endeavour?
So here at Endeavour, I look after strategic sales and our go-to-market strategy for AI infrastructure.
Okay. And for people who aren't as familiar with what that might mean, how would you describe? Are your clients cloud players and specific engineering buyers within those cloud players?
Yeah, so the focus is sort of twofold. It's one in terms of like an outbound, articulating the value of the technologies we've developed and the solutions that we've packaged together to customers or would-be customers coming from the technology space, whether that's GPU as a service or traditional hyperscale players. It's also ensuring that input and feedback they have is fed back into our product teams.
Yeah.
And then those products and services that we work to develop are effectively articulated at a marketing level and throughout that customer journey.
I love that. Otherwise we're just in an echo chamber, creating things that we think somebody might want one day without asking.
Yeah, it's just making it easier for the customer to understand the value in terms that they care about versus talking about a piece of equipment, products and product feature set. We try and turn that into what the value it is that it unlocks for the customers.
And how did you get here? Maybe to infrastructure as a profession in general?
Yeah, so I was really fortunate. I came to the States about 10 years ago, 11 years actually, coming up on now. Time goes fast. Plus we had those 2 years of COVID that I always kind of forget.
Exactly.
Maybe we'll get them back at the end or something. So I was fortunate enough to get picked up by a company called Corning Optical Communications, the people who make all their optical fiber. And they kind of gave me a crash course in technology. So this is at the OSI stack level, layers 1 and 2 and 3, so networking and layered networking. And from there, I was working with a customer that was in data centers, and I thought, wow, this is really fascinating. Co-location was getting bigger and bigger at the time, and I had the opportunity to move across there. And then I got to this data center company, and they had a cloud computing arm, and I thought, wow, that looks really cool. So I went over there and started working very closely with engineering. And while I was there, I was fortunate enough to work with the former director of research computing at Novartis. So back in 2016, 2017, we were building scale-up AI systems for high-performance compute in healthcare life science. So I was early into this.
Yeah.
I can remember him telling me I should be buying NVIDIA stock when they were mostly just
Did
known
you do
for
it?
gaming.
Did you do it?
Not enough. A very small amount.
Otherwise you wouldn't be here right now,
Yeah,
James.
exactly.
Yeah.
So that was really interesting. And then I just kind of kept chasing going up and up the stack, because that seemed to be at the time where more of the action was happening.
Yeah.
Infrastructure, while it moved, it just wasn't moving at the rate of software development or the things that you could be doing. So, better code could overcome a multitude of sins at the infrastructure layer. Rack densities, bringing it back to a data center standpoint, yes, they were going up, but they, weren't really going up by all that much. It was very, very incremental. And really the rate of pace of change that I've always found appealing was happening, at the higher orders of the stack, at the software layer. So I then went from there. I had the opportunity to go client side and lead technology operations at a healthcare company. And that was, really eye-opening, being on the other side of the vendor landscape, seeing what made good vendors, what made bad vendors, how they could make your life easier.
I didn't know that about that would really make a difference. What's an example of a bad vendor?
Transactional ones with very short-term mindsets. People who also let the customer have too much choice. Now, don't get me wrong, letting the customer choose is really important, but particularly if you are the innovation company. So if you're a cloud company and you are innovating and building these products, you should have a defined point of view on what good looks like for that product, for that service, how you should implement it, how you should use it. Not sell a brand new service or technology to a customer who is trying to very actively learn and catch up about what this new technology or service is. And you don't offer them quite prescriptive guidance. So I actually felt like what made very good vendors were people who had a point of view about their products and services, particularly if they overlapped, which ones you should use and why, and how best to implement it. That really helped from the customer side, ensure that you extracted maximum value from what you were spending money on. So that was one of the sort of key lessons I learned there. And then from there, I ended up at AWS, where I led go-to-market strategy for high performance and accelerated compute.
Amazing. Is your job now very similar to what you had at AWS, or is it pretty different?
No, it's different in a way because we're a smaller, more agile company, and so my ability to implement rapid change and affect change in a short order is far simpler here than at such a large company. And they did an exceptional job for a company of their size, but at some point there's something really appealing.
You have to become more bureaucratic the larger you get. So do you actually have say over the product development team? Like, can you go into the TurboCell team, say, you guys, this is really important?
Yeah, so I'm really fortunate to work with some brilliant engineers who are far more intelligent than I am. So what I try and do is just take pain points or feedback that we've received and ensure that it's embedded into go forward design. And I work really closely with folks like Wes and Chris Ellis to ensure that that feedback is captured, and as we're driving towards something we bring to market, it's being effectively incorporated into the solution we provide.
That's fantastic. That quick feedback loop, it's a very biomimicry thing, by the way. Nature survives on quick information flows and quick feedback loops. So if we can do that here, all the better. Yeah.
So that's one of the really interesting pieces. Also, I think if there's one other difference, is one of the things I saw or was seeing was I spent my whole career moving away from infrastructure, going up stack.
That's right. I was going to ask about that.
With what had happened or what was happening with AI and the impact that was having, that value chain was actually collapsing back down to the hardware and the infrastructure level. And now infrastructure was becoming critical and strategic and was ultimately becoming the rate limiter to discovery. So, the other really interesting piece of this role is I think I'm right back dealing with something that is at the very crux of the problem we're trying to solve if we're looking to accelerate AI outcomes.
I want to go back to my reference to you being the James Bond of Endeavour, of course, but maybe talk a little bit about, so even before you were in tech, you were in special forces. What was your job?
So I was a British commando officer, and I was really fortunate to be part of a specialist maritime counterterrorism team. So we focused on international maritime counterterrorism and counter-piracy. So it was a very dynamic role, as you can imagine, very enjoyable role. But, one of the things I think that it teaches you, being in the commandos or elite infantry anywhere, is the ability to very rapidly synthesize information and actually determine what is critical in that information. And so what I like about moving into very fast-paced environments is, number one, You're trained to have very good frameworks to learn things very quickly. So being able to learn things quickly is important when things are changing very quickly. And number two, in a world where there is a lot of noise, actually cutting through that to determine, which pieces of that noise is valuable, and how do you message that and ensure that, you're really driving towards the critical piece of information versus just noise.
Because you can't possibly respond to all of it.
You can't possibly respond to all of things. It's so multi-threaded.
I had thought about that. It's a great analog for what you do now.
Of the 20 possible pieces we could look at to, move the needle. And normally all of those 20 things can have impact.
Yeah.
Which one of those things is the thing that we can move the needle on fastest and soonest? So
do you think I often quote this, it's a question of sequence, that they will ultimately all be important, but the sequence matters that you go after. And do you agree? And maybe, answer that.
I agree. I mean, there are so many things we can do to chase performance and efficiency improvements in AI infrastructure. Some of the things are more easy to do than others. Some of them have more mature technology ecosystems existing around them today. So, normally that's a good place to start. Some of them will have bigger impact than others. So all things will have an impact, but it's moving the big rocks first and then dialing in from there.
Do you think it's easier to solve multiple problems at once though sometimes? Because it could be that a different paradigm is required. I'll give you an example. In the world of biomimicry, fans have sort of been the same design for a long, long time. And it's all about pushing air at greater and greater levels of efficiency. What's changed is there was an innovator who realized that nature often pulls through vortices rather than pushing. And so he created something that looks a lot more like a corkscrew that pulls, and the fan efficiency went massively up. The noise factor went way down, and you had a radically different design. And I think it's because he was definitely trying to emulate nature, but he was also trying to sort of solve for multiple problems at once: efficiency, cost, and ultimately and performance, but also sound. Do you think that sometimes it does help to look at multiple factors at once?
Oh, it definitely does. I mean, I'm just talking about if you're looking at a particular problem, there's normally one lever you can pull to get the impact soonest. But definitely in the environment we're in, co-design and co-innovation is the name of the game. I mean, if we look to how we got here, particularly in the data center industry, you had people developing hardware, the best AI hardware they could possibly develop. And they developed that not entirely in a silo, but they developed that at a rate that it basically outstripped the rate of change in infrastructure. Yeah. So now you have a company that manufactures chip IP in NVIDIA, then being very, very proactive in terms of encouraging the entire ecosystem to collaborate and design and innovate to solve the problem of getting their hardware into customers' data centers. So I think in the age of AI, we've realized that you can't look at these things in silos. You've got to have vertical integration. You've got to minimize handoffs. You've got to understand the impact across a grid-to-chip ecosystem in order to optimize for both performance and efficiency. So we definitely do need to look at a lot of things in tandem, because if you make one decision in a silo, it can have massive ramifications, across that entire continuum.
That makes perfect sense. So maybe with that in mind, what's coming? We've heard these different projections around 945 terawatts of power being used by 2030. What are your thoughts?
Yeah, so my thoughts are that is absolutely going to happen. So, which
would be more than double where we are today, yeah?
More than double where we are today.
Yeah.
And there's, a strong reason for that, and that is AI scaling laws. So the AI scaling laws really underpin what we're seeing in terms of this unprecedented rate of investment and build in the infrastructure world. And that is that if you scale a number of things, namely model parameters, data set size, and compute, your AI models get better in a predictable, consistent fashion. So it is that predictable and consistent fashion that is encouraging these tech companies to spend hundreds of billions of dollars on building bigger and bigger compute clusters, because there is return in terms of value and performance of their model. And that improved performance of the model, that makes a difference between being a market leader and not being a market leader. These companies haven't historically spent, from a CapEx basis, anywhere near the amount of money they're spending today, and is really those AI scaling laws that are underpinning this investment and driving them to continue to do this. And so that's not going to slow down, because actually we haven't got to the point in AI scaling laws where we see diminishing returns. So at some point when, and the law does state at some point those returns do diminish, but we are so early in this process that we're certainly not seeing that.
Yep.
And so when those returns start diminishing, we'll see a slowdown, but what that means is in the near future, we are not going to see a slowdown, in my opinion, in terms of the rate of development and building that we're seeing
So
today.
it could be higher than 945 even.
It absolutely can be higher, yeah. I think we're doing things, and some of the reasons it can be higher is the assumptions made in that model. Traditionally it took 3.5 years to build a data center.
Yeah.
We can now build data centers in, actually the longest piece is the planning, the permitting.
Yeah.
The actual building can be done in months, not years. And so, when that starts happening more and more, and we continue to innovate to drive speed to market, both at the infrastructure level, at the hardware level, I think those predictions will end up looking conservative.
So the thing that I left 20 years of sustainability to come into work in a data center and an infrastructure company, a solution company really. And one of the things I get excited about is, could that rapid demand actually drive alternative renewable energy sources? Because at the end of the day, it doesn't, coal doesn't pan out or doesn't pencil anyway. And so turning back on all of our old coal plants probably wouldn't even meet the need regardless at the cost we need. And everyone sort of recognizes the environmental cost. But do you think that heightened demand will actually be a beneficial driver for new energy sources?
Yeah, I think it is going to be a beneficial demand for new energy sources, because energy is becoming a very, very finite resource.
Yeah.
We are also going to see a big move towards distributed versus centralized energy.
Say more about that. Basically regional energy hubs.
Local on-site, like at point of data center energy.
You will be your own substation.
Yeah, correct. Transmission is extremely difficult to build a transmission network from a central generation plant out to a data center. Much faster, rather than waiting for that transmission system to be built. Also, there's loss in that transmission system.
That's right.
If you just bring the power direct to where the data center is, it drastically reduces your time to market. And then really what it's going to come down to in terms of that is the most efficient way to deliver or generate energy. So we will see a much broader mix that is going to take into account that drive towards efficient energy generation. So, in some of the places we're looking at, solar is going to play a big component in that, because you're going to have periods of time in the right conditions where solar is going to be unmatched in terms of a cost basis for energy generation. You're still going to need baseload power, and we have a number of technologies that are going to help with that, but it is going to be definitely a catalyst for introducing more and different methods of energy generation than our traditional centralized models of generation.
That's right. Going back for a second, as you think about these increasing demand and increasing scale, how is that landing with communities? You recently had a town hall, you attended a town hall meeting where one of our data centers was being approved. What was the temperature in the room? What did you hear? How did you respond?
Yeah, so I think the temperature in the room was mixed. You have people who are extremely excited. I think people can see the impact that bringing these things has to a community.
Yep.
In terms of investment, jobs, just the sheer scale, the length of period of time that these things will now be being built over. They're much more long term in terms of immediate impact from a job creation standpoint. I think also the fact that these facilities attract high-tech companies that are willing to make investments in the community is also something very beneficial. But right alongside that, there's a lot of bad press about data centers, and people are understandably nervous about having data centers come into their communities. I think part of that is actually because now things like power are a finite resource, it's driving a very different lens in terms of power efficiency and power utilization than there traditionally had been in data centers, where power was plentiful and actually chasing those incremental efficiency gains. It was just cheaper to get more power and be inefficient. We've left that world behind, but from a power standpoint, from a cooling standpoint. And so
that's really interesting. I just have to pause it. That's really interesting. That's such a different reality than we've ever been in. There's not just more to get.
There's not just more to get. And when there isn't more to get, you start focusing on how to be as efficient with utilizing that finite resource as you can possibly be.
Yeah.
And you hear talk about that, in terms of optimizing the number of tokens you generate per watt of power. How do you do that? That's actually the mark of an efficient facility. And so we're starting to see that more industry-wide. Of course, here at Endeavour, we've been doing that for much, much longer than that. It's always been a hallmark of what Jake set out to do even before he was here at Endeavour. So maybe rightly so, data centers have got a bit of a bad rep, and there's still actors out there who are doing things the most expedient way. Example of that is the cheapest and most efficient way traditionally to cool a data center has been to directly evaporate water, use some sort of direct evap technology that consumes millions and millions of gallons of water a year. Now at the scale we're building, at the size we're building, that is utterly unsustainable. And now people aren't just asking for a little bit of water, they're asking for monumental amounts of water. We aren't building 30, 40 megawatt data centers, we're building multi-gigawatt data centers. Okay. So, it's fundamentally different in terms of those resource demands. And so water was actually probably the biggest thing that, stakeholders in that town were concerned about in terms of a data center development coming in. So having, ultra efficient waterless cooling technology was an extremely beneficial way to placate the room.
And they didn't know that. They didn't know that. They didn't know that we had waterless cooling.
They didn't know that. No, because there aren't really sensationalist articles posted about the evils of data center that actually say, oh, not all of them do. They kind of focus on, those bad actors. And, we are very early in that space.
Yeah.
We spent a lot of time convincing people that actually waterless is the way to go, and you can drive the same efficiency you can with, even the most efficient direct evap systems. But again, when we get into these scenarios where speed to market is important and efficiency of resource utilization is important, to kind of reframe that argument. With waterless cooling, we don't need to go out and get those permits. We don't need to go out and secure that water source. It's a dependency we've now taken off the table.
It's huge.
It's a permitting piece that we don't have to jump over, a hurdle we don't have to jump over anymore. And we don't take any performance penalty because of doing it. And so it was really nice to actually be able to get rid of 90% of the people's concerns about a data center coming into town with a technology that we've pioneered, developed and brought to market, and now are using it ourselves.
That makes me happy. And I'm also excited about the idea of us capturing water, even certainly in drought-ridden regions like Texas or the Southwest in general, or even the American West. But also, just why not bring water where we can? You know, do you think that we can sort of counterbalance the bad press that's out there?
I think we can, know, whether everybody does. Yeah. I think we're going to reach a point where you're going to have to, because even just talking about scale, accepting something, one data center that's a 20 megawatt data center in your town is a very different, kettle of fish to accepting a 5 gigawatt data center in your backyard. So there is going to be a lot more impetus.
I think the thing I get most excited about is that we can move to sort of a positive. Maybe it becomes energy positive in a region, water positive in a region, just because we showed up, right? Just because we chose not just to be waterless in terms of our cooling, but maybe also capture rooftop water, maybe also do desiccant wheels. We can be a resource back to that community. Do you think that that's something that we can convince others of?
I think we can definitely continue to lead the market in that. I think others are going to have to be convinced. It's quite easy to hide a 15, 20 megawatt data center in a community. I'm sure people all over the place already live pretty close to data centers and have no idea that they're living there. But when you start building at multi-gigawatt scale, you can't hide that.
You cannot.
So it's going to be very obvious, and it's going to have a lot more optics on it in terms of the local community. And so anybody who wants to build at that scale and wants to build with a heavy impetus on speed to market is really going to think about how you overcome these community concerns. We're going to have to work much, much closer with communities in order to keep on driving the AI outcomes we're driving towards. So that is definitely going to lead to data centers in general across the board becoming better custodians and looking to actually bring much more lasting value to the communities that they are building in.
So speaking of that, what's the most enticing use of waste heat that you can think of? I mean, we heard about at the Olympics in 2024, they were heating pools with district heating. What do you like for waste heat? Yeah,
I think rather than wasting it, reusing any waste product or any waste stream from a data center is really important. That did a great job of, raising awareness for how to do it. I think the next iteration of that is going back to how you were talking about not wanting to do things in silos, or there was, actually you need to look at something as a whole rather than looking at a data center being the entire scope of a project. You actually start day one master planning these campus environments to be multiple use campuses. So it's not just a data center out in the middle of nowhere.
That's right.
Because the thing about having, capturing waste heat and then having the ability to use it is you need something to use it on to make that make sense. And so it's got to be a mind shift change away from just building data centers to looking at, building more holistic communities where we can take that waste heat and we can use it for district heating or, other beneficial uses. There's ones with greenhouses as well that we could look at. But I think those things have to be looked at day one rather than, build the data center first and then we'll worry about all that stuff afterwards. Because inevitably, if you leave it to afterwards, it becomes infinitely more complex to do it than if you just master plan it and do it up front.
Will data centers continue to get bigger and centralized? So energy systems may be decentralized around these data centers, but will the data centers themselves, edged as a term came up with this idea of smaller data centers, regionally located near urban environments, but now we're seeing I'll put a data center anywhere in the middle of nowhere if I can make it a 2 gigawatt campus or more. What do you think of the future? Do you think the future ever comes back around?
It definitely does. We've seen this in computing time and again, from decentralized, centralized, decentralized, centralized.
Yeah.
I think in the near term, we're going to continue to see very large centralized campuses just because that's where you get maximal benefit in terms of AI cluster usage. But, talking to customers like Meta, they're looking at now, rather than doing, if we just rewind the clock 2 years ago, a cluster was a subset of a data center.
Yeah.
3 years ago now. It was a subset of a data hall. Then it became a data hall.
Yeah.
Then that cluster became a data center.
Yeah.
Now that cluster is a campus. The next thing they want to look at is how do we then make, multi-campus clusters.
A city.
And so that starts decentralizing that as well.
That's true.
Also, as we move away from a time that is dominated by AI training. So, AI clusters, pumping out better and improved AI models, to the uptick in use case and integration of those of AI. We will see this sort of division between where we go and do training, probably still predominantly at centralized large data centers, and where the inference happens, closer to the edge, closer to the people using it, closer to those use cases.
Interesting. You just made me think of, so in nature, they're called ecotones. So when the forest meets the river, that's the richest in terms of biodiversity. Wherever two ecosystems come up against each other, that ecotone is fraught with life. And I'm wondering if the future is, if we get good at using waste streams, not even just our own, but also food waste, plastic waste, fashion waste, and those things start to subsidize the bill for a data center even, and we create new materials out of it with our waste heat, whether that's from greenhouses or algae ponds, new practices, and we're water positive. I wonder if there could be a richness of ecotones created because we've centralized all of these resources, and then the cities and the urban use cases are right there. I wonder if there's an analogy there.
Yeah, I think with what you're talking about, it would be nice if there's still heavy centralization, because ideally what we're trying to create is bring value to a place where there probably wasn't value or as much value before, versus in a city, you might have elements of that value already at place. Those broader ecosystems, urban planners have been thinking about that for a long time.
That's true.
Some of the centralized places we're going, maybe they haven't had any of that benefit, and we can be the catalyst as those large centralized campuses to bring it. But I think over time, we will see there's a heavy drive to be more flexible, more agile. Right now, we're limited by the technology sets that we have available us today from a networking standpoint, in terms of how we can do training. If we scale that wall, we'll increase decentralization again, but then we want to be careful that we've built these large centralized campuses that they continue to have lasting impact to those communities and ecosystems we've built around them.
That value. That's right. Are you, so again, back to James, the prognosticator here.
Yeah.
What are some of the, you can go either way. Let's start with, what's a leapfrog technology that you think right now might be a little bit in the science fiction-y category, but will probably show up as real?
So I think the leapfrog technology it isn't science fiction, it's more real than that, but it's not next 2 or 3 years real, it's maybe a little bit longer than that, is going to be new networking technologies that allow us to break out of this scale-up copper domain that we're trapped in. So right now, a lot of what's driving these densities is the limitations of an alternate to copper for scale-up networking. And so we've got to keep that power efficiency and that performance that you need for GPU to GPU networking in copper. That's leading to bigger racks and denser racks.
Yep.
That's been driving a lot of what we've been chasing for the last 2-3 years in the AI infrastructure space, because we've got to catch up with these rack densities that have all of a sudden gone from 15-20 kilowatts a rack into the hundreds of kilowatts a rack, and now we're talking megawatts a rack.
By the way, is that true? Megawatts per rack?
It's coming in the not too distant future
crazy.
On current trajectory.
It's crazy.
Where what some of these new networking technologies will enable us to do is disaggregate racks again. So go away from building bigger, like physically bigger and denser racks, to new architectures where we can now spread that scale up domain across a larger footprint in the data center at lower power consumption. And we'll probably find, some happy medium where we get optimal price performance. And I'm just imagining it's probably not going to be at, having multiple 2 megawatt racks.
Yeah.
I think from a price performance standpoint, we're going to find it's below that. So I think we're going to see rack densities go up and up and up. And then we're going to reach a point where we actually start to see that plateau and come back down with some of these new networking technologies that are coming.
Sorry, I'm like peppering you with so many biomimicry terms, but they're really just coming up. Another sort of like truism in biomimicry is that nature optimizes, it doesn't maximize. So I feel like a lot of what humans try to do is we maximize an opportunity, but nature's actually always looking for that appropriate balance or optimization path. And that's to be what you just described.
Yeah, so right now we're just, I think, going back to what I was saying earlier about with the technologies we have available, how can we have the most impact? That normally comes first, right? So we're in that phase where we're just chasing performance.
Yep.
And then when we've got that nailed down, we start looking at, well, how can we get that performance with better efficiencies?
I like that.
And so I think, this is going to be one of those technologies that is going to fundamentally shift a lot of what has been driving the data center industry over the last couple of years, and it'll continue to drive it for the next couple of years. But it's going to be really interesting when we get a technology that allows us to break out of these copper scale up domains. That's going to be the next really interesting moment in AI infrastructure ecosystem development.
What do you think within our sector, or maybe just within this realm of sort of the rise of AI in general or data centers in general, like what's a core issue or problem or challenge coming for society that maybe not everyone has their eye on?
Yeah, I think,
even if we don't know how to solve it.
No, I think we don't. I think it's articulated in a lot of ways that there's, we've got a transformational technology here. How do we use it to maximize societal impact in a way that's positive for humans?
Yeah.
I think if we look at, what happened in the era of the internet, the iPhone, there is, undoubted benefit, a lot of societal benefit that's come out of that. But on the flip side of that, there have been a lot of negative consequences, particularly with social media. If you look at things like depression rates and some of the concerns about people becoming very insular, not being great at, communicating. There's been impact in terms of polarization because now algorithms will just feed you more of what you want to hear, and it keeps you going down that rabbit hole and further away from a, sort of centralized viewpoint. You very rarely get exposed to other arguments or viewpoints. Yeah. Unless it's even done so just to carry on getting you excited about, your particular end of the spectrum you sit on. So I think there's been, an undoubted amount of good that's been done for society by the internet, widespread, very easily accessible media, but there's also been a lot of negative consequences because I don't think we knew how to deal with it. I don't think we knew how to gear up a generation of humans who are going to experience that. I mean, I myself grew up before the age of, there was internets and cell phones, but internet was a very slow dial-up connection. You couldn't really do much on it. Wasn't very exciting. So going from that to now being in a society where it's at my children's fingertips.
Yeah. From
the moment they're born, they're exposed to the entire internet. How do you deal with that? It's really challenging as a parent. Yeah. It's even more challenging from a government level with new technologies coming online to ensure that when these technologies do come to bear at scale, they're actually benefiting humans and not detracting from the human experience.
Even if we don't know how to solve for that yet.
Even if we don't know how to solve for it, we should be thinking about it.
We should
be thinking about, where do we strike that balance between and who gets to control that balance? These are very challenging questions, but it's
They're-
something that we should be thinking about.
These are philosophical questions almost. You mentioned your kids, and brings me to my last question, I think, which is, what do you think their jobs are going to be, or what do you think their relationship to technology overall? I make jokes to my nieces all the time, like, you're going to have to help me reset my hologram machine, which I'm sure I will have, and you will mock me for my inability to use it.
So I think that technology is moving faster than robotics. So you're probably better off doing something with your hands.
Yeah.
So I think...
Learn how to carve, learn how to weld.
I think something that is going to make you, if I'm looking cynically at this, harder to replace by technology. But on the flip side of it, I actually think in a world where we spend so much time on the other side of screens, just consuming content and not doing, just passively consuming, at least by having a job where you're physically doing something with your hands, I think will be extremely rewarding, especially going forward.
There's a book written, I think it's called The Case for Working with Your Hands, Why Office Work is Bad for Us, but they didn't even talk about the future of sort of like advanced digitization. But yeah,
I mean, I had a previous job where I worked with my hands, and that was extremely rewarding in a way that
our cognitive skills are wired for using our hands. So
it's hard to replicate that level of reward without doing something with your hands.
So do you think you'll go back to it? You think you'll go back to...
No, I'm good here now.
No more underwater knife fights for you?
No, not for me.
James, this is such a pleasure. Thank you for being on the show with us, and really grateful that you're part of Endeavour.
Thank you. Thanks for having me.
Yeah, it's our pleasure. Thanks, everybody. We'll see you next time.